Hi, it's Jakob again, and this is the second example from today's problem set about divisibility. Let's just jump straight into it. Okay, so what do we have is we have number b. Let's write its prime decomposition. We know that there must be some frees. We don't know how many of the frees are there, but there must be some, and so I just wrote them explicitly here. There might be only one, so don't be suggested too much about this. But there are also some other prime numbers, right? We don't know how big b is, just like in the previous example. Now write b squared primes the decomposition. Again, every single number can be expressed as a product of some prime numbers, and this is the case as well with b squared. In this case, we know exactly what it is because we can just square all the numbers that exist in this one, right? This is still like a normal product. If we square the whole thing, then we square every single factor. This just works normally. What this tells us is that even if those two numbers, those prime numbers repeat among each other, the total power in which they appear in this decomposition will always be an even number. So there'll always be an even number of frees. If you think about primes as building blocks, for a square, there'll always be an even number of each building block. There's always be an even number of each prime number in the decomposition, right? Again, a number of frees in b squared's decomposition is always twice the number of frees in the b decomposition, so it must be even, right? If there are 3 frees here, there will be 6 frees here. If there's 1 free here with 2 frees here, if there's 8 frees here, there will be 16 frees here. It's just how it works. The squaring doubles each factor, doubles the number of times that each factor appears there, right? So now we know that there are at least 3 frees in b squared because it is divisible by 3 to the third, which is 27. Divisible by 27 with 3 to the 3, so we can divide it by 3 and then divide by 3 again and then divide by 3 again, and there will still, and we're always able to do this, right? So that means that in this decomposition there must be at least 3 frees, right? But the number of frees in this decomposition is always an even number, right? So there cannot be exactly 3 frees. If there are 3 frees, there must be a 4th free, right? And if there is a 4th free, that means that b squared is divisible by 3 to the 4th, right? So if there are 3 frees, then we need to have an additional 3, and that is just equal to 3 to the 4th, 81. So that means that there are at least 4 frees in this decomposition, right? So that has to be equal to 81 times something, because 81 is 3 to the 4th. And this is this entire problem, basically. This is it. Right. Thank you very much for listening, and see you in the next example.